Intermediate Algebra Homework 31 starts off with where we left off. We are finding the roots of a quadratic equation. This time our leading coefficient is greater than 1, so our factoring is a little bit different. I have to be careful on these ones that I get it in the proper order before I try to solve this. First of all, whenever we're working with a squared term, we want it equal to 0. This is not equal to 0. Then what we're going to do is we want to make sure the w squared term stays positive, and we're going to move the other numbers over to make sure that the squared term stays positive. So in this case, I'm going to have 5w squared. I'm going to move this over, so it's going to be a positive 17w. I'm going to move that over, it's going to be a positive 6 equals 0. Before I factor, I got to make sure everything's in the right order. The squared term, the plain w, the constant term without the variable on the end. If it's in the wrong order, it's not going to factor out right. So you have to make sure you get it in the right order. Now I'm going to solve by factoring. Factors of 5w squared, 5w and w. Both of my signs are pluses, so I've got a plus and a plus. Factors of 6. Most likely it's 2 times 3. It might be 1 times 6. I want 17 in the middle. So I'm going to use the 2 and the 3. 5 times 3 would be 15. 15 plus 2 is 17. So 15w plus 2w is the 17w in the middle. The more you do factoring, the easier it gets. If you have to put them in, check it. If it doesn't work, switch them around, check it. If it doesn't work, try the next pair of numbers and keep guessing and checking until you find the right pair. Since these are equal to 0, I can now break it down into my 2 easier problems. 5w plus 2 equals 0, or w plus 3 equals 0. I'm then going to solve. So on the first one, I got to solve 2 steps. I'm going to minus my 2, 5w equals minus 2, and divide by my 5. So w equals minus 2 over 5, negative 2/5. My other one, I just have to move the 3 minus the 3, so negative 3. So again, if I really wanted to check that out, I'm going to take those answers and plug them in to see, does this side equal this side? Just because it's easier, I'm going to check the negative 3 and not mess with the fraction. But here's what I'm doing. I'm going to say it's 5 times negative 3 squared, 5 times negative 3 squared equal to negative 17 times negative 3 minus 6. So, checking that out. Negative 3 squared. Negative 3 times negative 3 is 9. 9 times 5 is 45. On the other side, negative 17 times negative 3. Negative times a negative is a positive. Let's see, that would be 51. So I get 51 minus 6. Well, 51 minus 6, sure enough, is 45. So when I put negative 3 in, both sides are equal to 45. I could do the same thing with the negative 2/5. Both sides should be equal to each other. If I use some other number, I'm going to get 2 different answers. So if you really wanted to check, I'd probably just grab my calculator and plug the numbers in and check. Does this side equal this side? Did I do it right? Number 2. Again, I'm solving a quadratic expression. I want my x squared term to be positive, but I want it equal to 0. I'm going to move this and I'm going to put it over here. I'm going to make sure I put it in the middle because the x term goes in the middle. So I'm going to have 4x squared. This was a positive 7x, so I've got to make it a negative 7x. Minus 2 equals 0. So you got to make sure that x term goes in the middle when you move it over. Now I can solve by factoring. Now this one's a little trickier to factor because 4x squared might be 4x times x, but it could be 2x times 2x. I really don't know. I'm going to start out with the 4x and the x. If that doesn't work, then I'll try the 2x and the 2x. My signs. The end is negative, so I have 1 plus and 1 minus. Again, I really don't know the order. I'm just going to guess and check. If I get the right number in the middle but the wrong sign, I'll switch them. Factors of 2. 1 times 2. I want to get a minus 7. So if I take 4 times 2, 4 times minus 2 is minus 8, plus my 1, negative 8 plus 1 is negative 7, and I've got it factored out. I'm then going to set each of my factors equal to 0. So 4x plus 1 could equal 0, or x minus 2 could equal 0. Solving each of those, minus my 1, 4x equals negative 1, dividing by 4, x equals negative 1/4. Here, just adding my 2, so negative 1/4 and 2 are going to be your solutions. And the third one. Again, I've got the quadratic expression, but it's not equal to 0. I want to move this to the other side since it's the constant term I wanted on the end. So 9v squared plus 30v. Since this was a negative, it's going to be a positive when I move it to the other side. I now have to solve by factoring. Now I have 9v squared. It could be 9v and v, but it might be 3v and 3v. Normally when I've got a big number, I do the 3v and the 3v first, and then if I need to, I'll switch it to the 9 and the 1. Both of my signs are going to be pluses, since both of these are pluses. Factors of 25, probably 5 and 5. Checking that out, I'm going to get 15v plus a second 15v, and 15v plus 15v is 30v. I forgot to put my v on there. 30v in the middle. So this is what's known as a double root. I'm going to get the same answer twice. I don't have to solve it twice. I'm just going to solve it once because I'm going to get the same answer either way. So if 3v plus 5 equals 0, I'm going to minus my 5. 3v equals negative 5 and divide by my 3. v equals negative 5/3. And I'm just going to have one answer because I really would get the same answer twice. Negative 5/3. The next one, solving